The next topic, which of course is construction. We're going to go behind the scenes. Now, we were planning on going live onto the site. It turns out that the Big Mac said he waits for no one, including all of you and our listeners. And he's just poured concrete. It is soaking wet. And he said, unless we're all there in gumboots, we will not be there. So I think he's going to share some photos. But before that, I wanted to have a little bit of a chat with him just about the industry. So Big Mac, come on in. Now, I think everyone would have to be under a rock. Good to see you in here. I love the suit color.
She's giving me this thing again. So
the microphone good now. We're going to have to clip it on. Let's just clip it onto your tie because I know you. Suits. That's all right. It's only $1,000 tie. Right, you can afford another one. Okay. You're rich. Did we coordinate
I
colors?
Think we did. Absolutely.
Okay. So for everyone out there, you know, you'd have to be under a rock if you haven't heard about builders going broke. You know, we just had 2 weeks ago, one of Australia's biggest national builders, ProBuild, in the high-rise space go bust, which is very sad, you know, thing I think for a lot of people out there that were subcontractors or that will be affected by this. We're even hearing some of the big, you know, volume house builders struggling, and they've even gone to the extremes of terminating contracts with buyers on yet to be built houses. You know, sort of saying we've got, you know, supply issues, price issues, labour issues, everything, which, you know, is pretty devastating for someone that you kind of say, well, you know, I've signed up. I thought I had a new house. I thought you were about to start and it terminates. So just tell us what's happening in the industry. What are you actually seeing on the ground, and why are we hearing these stories coming out like this?
Well, look, I mean, as you said, you have to be under a rock not to recognize the sort of geopolitical environment, what's happening in the Ukraine.
Geopolitical? That's a big word
again. Oh, sorry, I apologize. The environment right now is very different than it used to be. We've got increase in overseas shipping costs. We've got raw material costs and so on going up. And I think a lot of the way in which the industry sort of grew, you had these multinationals, overseas organizations buying what we would call tier one construction companies, you know, the big boys funded by, whether it's the South Africans or ProBuild or other organizations with money out of Asia. And when things go wrong, you don't necessarily have that local support of a financier or a leader behind the company to say, look, I'm prepared to tip my own money in.
Yeah.
So a lot of that cannon fodder created by companies like ProBuild going broke is really symptomatic of, you know, the Australian economy, what people view in terms of their ability to lose money or to suffer the increase in costs from construction.
Yeah.
So supply chain issues, all that type of stuff, it's very topical. And I think just as a developer, and if you consider how we've had to change, we used to be able to take the design process.
Just before you get into that, just for our listeners, because I think it's a point that's perhaps being missed by people. Can you just explain, you know, sort of the timeline around the contract? Because a lot of people would be saying, but I walk into Bunnings and the price is a price, that's what I do. Can you explain why this is becoming an issue? And because I think a lot of our listeners won't understand the timeline that's involved, you know, when things get agreed to when there's actually becomes a price issue.
Well, you're effectively talking about years. So when we take a design process, we'll tender it to a builder, 70% design as an example. They'll go out, they'll tender to their trades. By the time you execute the contract, add 6 months. And then of course you've got on a big project, you've got a couple of years to build it. So by the time they're putting the final screw in the building, you're talking about up to 3 years have gone by. And in that time frame, you know, you've got these sort of externalities happening, be it foreign exchange issues or overseas geopolitical issues that are having a massive impact on pricing. And someone's got to absorb it, right? And often that transfer of risk down to the subcontractor or the builder is what creates the issues in the industry.
Yeah.
And one of the things I was going to say before is when you look at designing a building, we used to be able to leave everything till last. You know, we wouldn't worry about what was going to be the tile at the common area on level 52.
Don't lie, you always worried about that.
Yeah, I did. That's true.
We're talking about the industry-wide
as industry as a whole. So we used to sort of delay things until later and sort of kick the proverbial can down the road. And the reason we did that is we had lots of supply, be it your local Bunnings store, which of course get the major materials from, or the tile shop that was sitting on large amounts of tiles and so on. The entire procurement cycle has changed. We are now taking designs of our buildings in particular, 80, 90, or in some cases for things like structure, 100% complete before we tender. The reason we're doing that is the traditional kick the can down the road approach is gone. We are now having to order materials early. You know, you've seen me out there, you know, trying to smash tiles and see the density of them. and we're warehousing a lot more materials with the builder than we've ever done before. That sort of just-in-time manufacturing process that we all got really comfortable with because we never wanted to put money out early is starting to move away from commonplace. And you're now seeing advanced procurement, off-site material allowances becoming more typical within these types of contracts. And that's really a byproduct of things like COVID-related delays, impacts out of what's happening with raw material costs, risk transfers, and so on. And I think one of the other interesting things is, we talk about the negative impacts on the economy of all these external things. But what we're seeing is a return back to Australia. So we're now seeing the decision to go overseas. We go overseas for windows, or we go overseas for car stacking systems. And people are now starting to say, well, when you add shipping cost, raw material increases, foreign exchange risk, well, now that question of offshore, onshore is starting to change.
Yeah. And I think I was going to bring that up before as well, that as you were talking about procurement and thinking about how you do it, that, I know because we've argued many times, we're best friends, but we fight like a married couple.
Isn't that how it works?
Of course. And, things where you've actually sort of said to me, listen, this is made overseas. We've got the slow boat from China bringing it because it weighs 25 million tons. And, you've actually made us spend and commit to a big amount of money building something offshore before we've even let the actual main construction contract, simply because you said, look, we're going to build this in 18 months, but we need this thing here 12 months before we're finished, and it takes 2 years to build. And there's some of the things, I guess, that perhaps some of the less experienced developers, and particularly some of the smaller, perhaps less, builders without as much cash flow don't realize. And they might get pricing from overseas, but you're telling me they've now got to go and deliver it locally, which can be, 20, 30, 40, 50, 100% more.
Absolutely. And you add in foreign exchange, you add all those types of things. That risk transfer issue, that we used to be able to just give it to the builder and then give it to the subcontractor. You now have risk sharing where everyone's sort of looking and forecasting what could affect the job moving forward in terms of procurement, on-site delays. And you sort of take this bipartisan approach. Now it's another big word for you, right?
Yeah, I don't know.
But you're no longer in your silo, just sitting there and saying, well, here's my contract and I'll hit you with it every time you don't do what you say. You sort of look on a more balanced approach. And if you look at us as a company, why do we start to look at these sort of smaller private organizations like MaxCon, and you were asking me about that before. MaxCon's a private company. The owner and the owner's father and the owner's family member involved, it's their money. They're not about to walk away and leave their subcontractors unpaid, and they're making sure that they don't do as many jobs. And hey, that's good because you can better control those.
Sometimes
jobs.
less is more.
Less is more. So, if you look at us as a business, we've said, well, multinational money coming offshore, risk associated with that. Let's go with the smaller guys. And these smaller guys are doing $200 million jobs. So, everyone's having to pivot and shift and recognize those risks and manage them and be proactive. And it was interesting, I never listened to you, so my apologies. But actually, it's better than it's actually bloody good. So, you talked about those.
We've got that
you got that,
now.
Cancel that part. But, those 3 pillars that you were talking about, that sort of proactiveness. And what reminded me was it was manage, finance. What was the other one?
And find.
And find.
You did pretty well. It's more than I thought you would have listened to.
So it's identical approach. We find the best way to deliver that project onshore, offshore, find the right product. We manage it closely, be proactive about it. And as you know, finance is key. How do we finance this thing? What's the financier's view going to be on risk? So interesting, those 3 pillars that you sort of put to everyone actually even sort of.
There you go. That's what we call a compliment, ladies and gentlemen.
And that is as close as you're getting. But
now,
so that was interesting.
You've made everyone feel inferior, like you are the smartest man around here. Usually I try to take that title, but right. Tell us, you're building right now. Surely you've got to have some issues. What is keeping you up at night? Let everyone know that you are human, that you are struggling from a few things. Surely there's got to be something that's worrying you, or maybe you've already overcome it. But what are some of the things that you've seen personally?
Well, although I look cool, calm, and collected, some would say like Jason Bourne. Yes, you didn't see that was a TikTok. I hate him for it, but everything keeps me up. We spend a lot of time, and as you know, I'm into virtually every detail, sitting with the boys, trying to look at everything from penetrations and slabs to where the windows are there going to be any issues. So look, I worry about everything, but I'm very fortunate. MaxCon's an extremely proactive contractor. great group of guys. And I think if you look at what we've done and some of the photos we might show here today, we've got windows up to level 18 and we're on level 10. And they're in the country, they're on site, they're sitting in a storage facility and they're labeled. And if you look around many jobs in Melbourne here, they're missing windows. Why? Procurement issues. And
that's that shipping issue we talked about.
Shipping issues and all sorts of other issues coming.
I mean, it's funny, the irony as well, because we had a bit of a funny conversation last week that the bank, when it came to funding that claim, actually said, why have you got so many windows here?
That's right.
You know, they haven't even gotten around the fact that, you know, if you're not being proactive, you're not ahead of the curve, you're going to fall behind because something's going to happen.
Yeah, and that's really that risk transfer thing. Everyone's concerned about risk. And I think, you know, we need to open our books. We need to have conversations about how we collectively manage it and then make strategic decisions moving forward. And I think having the smaller organizations like MaxCon and working indeed with some of the non-banks like MaxCap, unrelated, of course, you get that ability to have those conversations and think in the macro sense, how do we best manage the job to deal with the risk? Now,
before we transition and you show us some photos, can anyone else build without you? Are there other cranes out in the sky? I mean,
well, if we're asking
the way that we sound like it, surely if they don't have the great Big Mac, no one else could be building.
Barrio, the owner, everyone can. But look, we just try to do our best, much like you.
Yes. All right, good. Now, if you didn't catch it at the start, Colin was going to actually be taking us live onto site and showing you some concrete being poured, many things going, but you don't wait for us, do you?
No,
and if it's got to happen, it happens.
Well, that's right. We went up there this morning just to see how they were progressing, and unfortunately, far too quick for this. They'd progressed. I actually tore my pants on site too. So, but nevertheless, we got some photos that we can share with everyone. And as you know, I like to go into too much detail, so I presume you'll cut me off in about 10 seconds of going through the photos.
Well, if I can even get them rolling, I'll see. Let's just try. Maybe while I'm trying to do this, just let everyone know what.
So we'll have a look here. We're pouring level 10. Oh, that's a fantastic photo. I'm not sure whether I can get that. Okay. All right. So for those of you who haven't been on commercial sites before in the past, I don't know what you've done there, James.
So I'm just for everyone to get the full.
So on a commercial jobs, you know, if you've done a house in the past, you would see they'd have what they call square or rectangular ribbed mesh. It's those sheets that you see. That's quite common for housing slabs, and you might have some reinforcing bars. In the commercial space, it's quite different. We use something called post-tensioning. And post-tensioning is really about limited reels, thinner slabs, and construction sequencing. So what we're looking at here, James, there's the core, there is the jump form, if you can zoom in. And you can see the boys there, they've got this black
they look
pipe.
like they're knee deep in concrete.
They're knee deep in the concrete.
And you didn't want to do that with your slick shoes?
So just sort of scroll up a little bit the other way. So you'll see that there's a static line, that black line there is where the concrete's coming from. So there's a hopper on ground floor, pumps it up through this steel pipe and drops down. The boys are sitting there with their laser levels and obviously setting all the RLs of the slab. What you are looking at effectively is the post-tension strands, which are, I was about to try and do this, which
right, I'll drive for you.
So these are the post-tension tendons, and they go into the PT pockets. And effectively, this is where they pull strands that really create the strength of the slab. So concrete obviously has strength in compression and steel in tension. So what we do is the concrete forms, it starts to cure, and we tension it, and that creates strength in both directions. So effectively, once it's poured, we come in, we put a machine that hydraulically goes and pulls it and tensions it up. So you're actually looking at also here, if you want to zoom out a little bit, James. And you can see that there's a lot to these slabs. They're not as simple as some people might think. These here are all the electrical conduits that get cast in. So for those of you who have apartments that have exposed safeties, I hate conduits running on the ceiling. It looks terrible. So we've gone and used surveyors to come in and cast those, what we call locator flanges. So you get that nice light with no cable that you can see. And that's how we do it. We cast it in the slab. Here is actually the interface with the core. So we've got, if you just zoom out, pull-out bars just in that corner, James. It's just over here. If you want to zoom in there. No, probably can't. So these are pull-out bars that sit within the the form of the core, we pull them out and they tie in with the reinforcing that's going in the slab. And you can also see we've got some precast elements, and these are called dowel bars. And we land precast directly on them, and then we grout them through these grout tubes. So here, and Lucas actually was speaking to me about this before, and I had a great idea. We can show you over the next week or so, or whenever you'd like to do it. This is actually a shower base. So we put those shower bases in, and that forms up that recess, so you get that really nice finish in the bathrooms. So we can take you after and show you, where this bathroom was, and give you some context to all these fire colors that we're putting in for the risers. So you can imagine guys are sitting there, lasers are going, surveyors have marked all the key points, and these guys are concreting to it. It is not easy.
Now, the Q&A has totally blown up at the moment with people saying, I don't understand his accent, and the number of questions coming in, but I'm going to try and discern it down to a few quick ones for you. How many people would typically be here doing this kind of a pour?
Oh, you probably have, in this case, it's a small area. They cannot fit lots and lots of people. They might have 10 guys, a guy sort of dragging the concrete back, a few guys floating it off. This guy's controlling the concrete boom. There's people behind me, OH&S. Depends really on the size of the pour, but 10 to 15 guys.
So I'm not going to get through everyone's questions. I'm going to just try and ask Colin a couple and get it straight, because I think there's a few more photos you want to look at.
Yeah.
So just quickly, a few people, I found that really useful, but I understood most of the big words he was using there. So I think a lot of people heard what you were talking about post-tension, but just for those of you that want it simple, really what Colin was talking about is that typically if any of you have tried to do a slab, a stair, even a barbecue, it's a big thing on TikTok, making your own pizza oven and so forth at the moment, that you go to Bunnings, you buy, a couple of bags of concrete, and typically you go and buy some reinforcing in either a sheet or a few bars that you put in. And really what you're talking about when he's talking about the post-tension, he explained to you the difference between concrete being strong under compression and steel under tension. Really what it's doing is maximizing both those materials and adding to it, because obviously here is still the traditional steel reinforcing. This is just making it bigger and better.
Yeah, and you don't have the same magnitude of steel bars you would have under a normal reinforced concrete slab. That would also likely be much thicker.
Now, even my kids know what goes up must come down. I've seen a lot of people asking, how do you get the concrete to stay there in midair?
Well, that's a good question. And I actually have a photo.
Another photo?
And maybe we'll just go a couple of other ones and I'll show you.
Let's try.
Sharing screen is stopped. I mean, that's the best picture of all. It's back in my head. Okay, this is a great photo. Well, great for me, probably confusing for everyone else. So with post-tensioning, you'll probably notice that you've got this wave. I don't know if you can see that for people who are looking out there. This wave, it's effectively an amplitude of the tendons. And that's really determined by its position relative to support lines. So it's high over support and drops down where you're in the middle of a span. So you might think it's pretty easy, James. You go out there and you put your tendons on the ground, take your tape measure out 1.2 meters.
It's harder than that,
but every point along here is actually at a height that recognizes what happens when you tension those strands. So there's a lot of complexity.
So do they sort of go up or down?
Yeah, they go up and down. So this is a line of support. We've actually got a wet joint with all this huge N24 reinforcing bars sitting on top of precast. And that's why it's sitting high relative to the others that are further on in the span. And you're actually looking at bars that are dowels effectively for precast that'll be dropped on it later on. Again, each of the positions here isn't just guesswork. They're given centers by the structural engineer. That's got to be coordinated. And these effectively have to be precision perfect, because we're taking a pre-existing poured precast element and we're dropping it on pins. So and literally it has to go.
Just for everyone, when we talk about precast, second nature to us, can you give a quick helicopter, what is precast?
Sure. So there's a couple of ways in which you can do structural walls. You can actually cast them in situ. So effectively you form them up on site. You've got forms and you reinforce them and you pour them on site.
Which is what I think most people would.
Yeah, and we do that with the core elements that are very big. Or you've got precast. So it's pre-designed. Your positions for all your grout tubes are pre-designed. and you lift them in by a crane. You know, you're constrained by weights and so on. It just means that once you produce it and you bring it to site, it's not like you can move that bar and I'll knock that over and so on. It's literally got to sit precision perfect. So
it's obviously faster as well.
Yeah, well, that's right. Yeah, and those elements, and you'll see with our slabs, you know, these guys in the next couple of days will be dropping precast already, and that's how you increase cycle time. If you're forming everything in situ, and in fact, if you there's a couple other photos where we actually show there's a precast column already on site, and that's a good example of, you know, how we accelerate construction. We don't just wait for these elements to be poured and formed in situ. Oh, there it is in the corner. It's not a fantastic photo, but you can sort of see, so there's a Perry system. Maybe just go back to the other one, James, where it was sitting there in the corner. So not a great photo, but just in that right-hand corner, you can see a precast column sitting there.
I'm just going to share it with everyone so they can see.
Precast already done. You can see that the interface with the slab or the pull-out bars, that's all comes pre-done. So we don't have to form that element up. And that's a key structural component. So the boys will be able to very quickly cycle on to the next level. All this stuff has to be predefined before we even start pouring this level.
And obviously doing precast in terms of the quality of the finish and so forth is far superior because it's in a controlled environment.
Correct. Well, you're pouring it on beds effectively, and those are steel beds. You get amazing
I might
quality.
even do it because you're not out in the rain and the elements.
I doubt that, but
okay,
yes, but you've got, you know, it's the same process of carpentry and so on, but yes, it's absolutely more precise. And really, it's about speed, James. You wouldn't deliver these towers with the same speed if you had to pour every single element in situ. So this is actually the answer to your question. If you go to the next, oh, well, that's okay. So as you can see, we've got Perry props. As you know, I call them acro props because I'm Canadian and we use a lot of that stuff. And I was corrected on one of the people who said,
I'm an Aussie, I still call them acro props anyway.
Okay, we'll call them Perry props because someone was offended. So you've got obviously these props that are sitting under the grid flex system. This is by Perry. It's designed specifically for slabs, I think up to 330 mil. So what you do with this, effectively, you've got ply, so you've got your form ply that you put on top of it. Carpenters come in, complete that work, and they're literally laying, reinforcing, and they're post-tensioning direct on this.
Yeah.
So we just back prop that until we hit 28 days strength, and of course, in the cycle later.
So, you know, as I said, for most people, they're probably aware of trying to do a slab on the ground and, and it doesn't go. And you call this a suspended slab.
That's right.
But it's not suspended until you've actually done it.
Yeah, well, it's not
dry.
literally. Yeah, exactly.
And I think that's what a lot of people just don't realize. You know, perhaps if I zoom out, you know, these props, you know, they're at sort of what, 1,200 spacings between them.
Yeah, it really depends on the bearers of the system. But yeah,
so it's like a forest when we go in there. And I think
it is,
people have seen some other videos.
Yeah,
there is a ton of work that's holding that all together. And how long does this need to stay before you can take it down?
Well, as you know, concrete cure is 28 days. They're trying to cycle one a week. So they're back propping 4 levels. Once we pour a slab, we're removing it from 4 levels below and we're continuing on.
So for about 4 weeks, you'd say on average.
Yeah, and we're able to do work on top of it. So it's not like you can't land precast for those 4 weeks. It's really about it reaching its full strength. And some of the ways that we do it, obviously we have higher strength concrete and things that can help speed up time. But this system, you know, most of the high rises are built this way. Again, the position of all the props, the position of the bearers, the way the system interfaces with the core and precast must be predetermined.
Yeah.
If you get that wrong, it will not tie together and the structural elements won't work.
And I mean, I guess it's a little bit like for those of you that have put those 3M hooks on the wall, it tells you to wait 3 hours.
The picture and then the falls,
and you put it straight on that, you know, maybe you should listen to the instructions. And
well, that's right. Yeah. And you go get that heavy picture and it says 7 kg limit. You put 25 of them to try and think that you could get 20 kg. Yeah, I get it. Yeah.
Now, I love this photo. I know what it is. And we talked about it before.
Yeah.
Can you sort of just talk us through why have you given us this photo?
Well, they say a picture says 1,000, whereas this says 2,000. This is effectively the window. So this is a part of the site is a big warehouse. And this goes to my comment around procurement. These are windows up to level 18 in the country, pre-glazed, ready in stillages to be craned up to the floor. So this is sitting there. We're not waiting like many other towers around Melbourne here for windows. We have them.
Yeah.
And as you know, once you've got the windows, you strip the floor, you're right on to fit out. So you're chasing the structure much closer when procurement is tight.
So this is sort of like the IKEA store. all of these have been pre-numbered, pre-worked out where they go.
Yeah.
You crane them onto their relevant level, and literally the guys get them out.
It's
fit them
installed
in,
by
and
number.
away it
Yeah.
goes.
So if you ever look at the shop drawings for the windows, there's each of these elements. You can see the labels there. The guys go grab that element, look at their marking plan. That's where that window goes, and they continue to move on. Again, as you know, tower is about speed. Once you're enclosed, particularly as you get higher up. I mean, you were with me when we went to Palladium. You're 50 levels up. The wind is howling. The rain is coming. You want to get that building enclosed as quickly as possible.
In fairness, I didn't come to you until it was closed.
That's a good
if
point.
there were no windows, I wouldn't go.
Well, remember, I think we did a YouTube thing, and no one could hear me, and I ran down the stairs. So, yeah, enclosing the building is critical. And really, the way in which we develop is you've got to close the building first, and then that gives you time to make sure that we catch up if there's any other delays.
And that's, I guess, for a lot of people that have built a house or watched, the thousands of home renovation shows. Typically that's what they call in these shows lock-up stage.
Yeah.
That's what you're trying to do by getting it weatherproof, because last time I checked, plasterboard and water don't mix too well. Apparently electricity and water don't mix that well either.
Oh, that's right. Exactly. Yeah. And going to that point, we've already got our substation is in place. We've got all that stuff happening now. Again, that helps us with commissioning, managing, even local authority long lead time items.
All right, good. Now, we've gone way over time. There's heaps more questions. I think it's going to be too hard, as I said, to get through them. And I'm conscious that most of you probably have your lunch break ending in the next 13 or 14 minutes. And I want to talk again after my friend's stolen the limelight. So we'll cut it short there. But what we might do is just compile those questions and sort of try and come back to you guys individually or as a group. And definitely, if you haven't put any questions in there or there's other things that you want to see, as I said, it's all about helping you here. So, get involved, put your questions in, put your comments. Feel free to mock him because I'll do it later if no one else does.
Or mock you, even better.
No, I don't want to encourage that. But obviously, that's what will help us drive what we show you next. Hopefully you found this interesting and useful. And I've just realized no one can even see our wonderful faces because we still have the screen there. So look, put them in. We'll get back to you if we can, or we'll add that to be a topic to do next. And hopefully when some of the windows are in and it's not as noisy and wet, you might actually take us onto one of those floors and show us some other of the finishing trades. All right, buddy. Thank you. I will roll out and finish out. So thank you very much. And hopefully we'll see you soon again.